Imagine your body has an elite security force designed to hunt down dangerous intruders, like cancer cells. These guards patrol your tissues every day, scanning for anything suspicious, ready to sound the alarm and launch a full-scale attack. But what if the enemy found a way to whisper a secret code that turns these loyal defenders into traitors? That is exactly what some cancers are doing, and scientists have just uncovered the hidden conversation that allows tumors to grow unchecked. For years, doctors have known that the immune system can fight cancer. Breakthroughs in immunotherapy, treatments that boost the body's natural defenses, have saved lives and transformed how we think about cancer care. But despite these advances, most patients still do not respond to current therapies. Why? Because cancer is cunning. It does not just hide, it actively manipulates the very system meant to destroy it. Now, in a major discovery, researchers have identified a new way tumors disarm the immune response. It centers on a surprising player, a hormone that was once thought to play only a minor role in brain and nerve function. This hormone, produced by certain cells inside and around tumors, sends a silent signal to a specific receptor on immune cells, effectively flipping a switch that shuts down the body's defenses. The immune cells in question are called myeloid cells. They are among the first responders when something goes wrong in the body. When a tumor begins to form, these cells rush to the site, ready to coordinate an attack. They are supposed to activate other immune soldiers, especially T cells, the hitmen of the immune system, and direct them to eliminate cancerous tissue. But instead of fighting, something strange happens. These myeloid cells go quiet. They stop communicating. They stop attacking. In fact, they start helping the tumor grow. Scientists have long suspected that tumors send out signals to corrupt these frontline defenders. The big question was, what is the signal, and how does it work? After years of searching, the answer has emerged. A hormone called secretogonin 2, or SCG2, is released by tumor cells and nearby nerve-like cells in the tumor environment. When SCG2 floats through the tissue, it finds its match, a receptor on the surface of myeloid cells known as LLRB4. Think of it like a key fitting perfectly into a lock. Once connected, a chain reaction begins inside the cell. The myeloid cell receives a command: stand down. Do not sound the alarm. Do not call for backup. Pretend the tumor is not a threat. This single interaction changes everything. Without the myeloid cells sounding the alarm, T cells never get the message to attack. The tumor grows in silence, shielded by the very immune system that should be destroying it. It is not just hiding in plain sight, it is using the body's own language to convince its defenders to stand aside. To test this idea, scientists used mice engineered with the human version of the LLRB4 receptor. When cancer cells that produce SCG2 were injected, tumors grew rapidly, as expected. But when researchers blocked the LLRB4 receptor with a specially designed antibody, something remarkable happened. The tumors slowed down. The immune system woke up. Myeloid cells resumed their normal function, and T cells began to infiltrate the tumor. The body's natural defenses were back online. Even more telling, when scientists removed SCG2 from the equation entirely, the same result occurred. No hormone, no suppression, no free pass for cancer. The immune system recognized the threat and responded. This two-pronged conformation, blocking the receptor or removing the hormone, proves that this pathway is not just a minor player but a central control switch in the immune system's ability to fight cancer. What makes this finding so powerful is its potential to change how we treat not just cancer, but a range of other diseases. Immunotherapy has long focused on T cells, with drugs designed to release the brakes on these immune soldiers. But this new research shifts the focus upstream, to the cells that decide whether to call the soldiers in the first place. By targeting the SCG2, LLRB4 interaction, doctors may be able to prevent the immune system from being silenced before the battle even begins. And here is where it gets even more fascinating. While blocking this pathway could help the immune system attack cancer, doing the opposite, boosting the signal, might be useful in completely different diseases. Imagine a body where the immune system is too active, attacking healthy tissue. This is the reality for millions with autoimmune disorders like lupus, multiple sclerosis, or rheumatoid arthritis. In these conditions, myeloid cells can drive harmful inflammation, causing pain, damage, and disability. If SCG2 can calm these cells down, then delivering it artificially might offer a way to quiet an overactive immune response. It is the same mechanism, used in reverse. One switch, two possible outcomes. This duality is what makes the discovery so exciting. It is not just another cancer drug target. It is a fundamental insight into how the body balances defense and peace. The immune system must be strong enough to fight invaders but restrained enough not to attack itself. This hormone receptor pair appears to be part of that delicate balance. Tumors have learned to hijack it. Now, medicine might learn to use it wisely. The implications go beyond cancer and autoimmune diseases. There is growing evidence that inflammation plays a role in neurological conditions like Alzheimer's and Parkinson's disease. Myeloid cells in the brain, called microglia, are similar to the ones in the rest of the body and can become overactive, contributing to nerve damage. If SCG2 can modulate these cells, it might offer a new way to protect the brain. Early studies suggest this pathway could be active in the central nervous system, opening a door to entirely new treatments for diseases that have long resisted effective therapy. Of course, turning this discovery into real treatments will take time. The antibody used in mice is not yet ready for humans. Scientists need to ensure that blocking LLRB4 does not cause unintended side effects, such as triggering autoimmunity. They also need to find ways to deliver treatments precisely to tumor sites, avoiding disruption of immune balance elsewhere in the body. But the foundation is now laid. Pharmaceutical companies and research labs are already exploring ways to target this pathway, and clinical trials could begin in the coming years. What is clear is that this discovery challenges the old view of cancer as a disease that simply grows out of control. Instead, it reveals cancer as a master manipulator, engaging in a kind of molecular espionage. It does not win by strength alone but by deception, by speaking the body's language fluently enough to turn friend into foe. And now, for the first time, we are beginning to understand that language. This breakthrough also highlights the importance of looking beyond the obvious. SCG2 was not on anyone's radar as a major immune regulator. It was known to exist in hormone-producing cells and neurons, but its role in immunity was a mystery. It took a bold, open-ended search, scanning thousands of proteins, to find the connection. Science often advances not by chasing the expected, but by being willing to follow the unexpected. As researchers continue to explore this pathway, they may uncover even more layers. Does SCG2 interact with other receptors? Are there natural triggers that activate this system in non-disease settings? Could stress, diet, or other factors influence how much SCG2 the body produces, thereby affecting cancer risk or inflammation levels? These are the questions that will shape the next phase of research. In the end, this discovery is more than a scientific milestone. It is a reminder of the body's incredible complexity and its vulnerability to exploitation. But it is also a story of hope. Every time we uncover a trick that cancer uses to survive, we gain a new way to fight back. What once seemed like an invisible shield protecting tumors may soon become a target, and that target could lead to treatments that work for more people, with fewer side effects, and across a wider range of diseases. The war on cancer is not won with a single weapon. It is won by understanding the battlefield, by learning the enemy's tactics and turning them against it. This discovery is a major step forward in that mission. The silent signal that once allowed tumors to grow in the shadows has been detected. And now, the body's defenders may finally get the chance to fight back the way they were meant to. If you found this story as fascinating as we did, hit that like button, subscribe for more deep dives into the latest breakthroughs in science and medicine, and ring the bell so you never miss what's next. The future of medicine is being written right now, and it's more incredible than fiction. Share this video with someone who needs hope, who loves science, or who's fighting their own battle. Thanks for watching.